All right, welcome everybody. This is 3.2. We're talking about solving polynomials. Last time we talked about it when we had rational solutions, meaning like you could get whole numbers or fractions. Today we're going to add into when we could have irrational, like the square root of 2, or you could have imaginary, like where you had the square root of a -1, right? That ends up giving us an imaginary number. Okay, so let's try a couple really quick. A is just a review, so there's nothing going to be really different here, but I would like to get into like what we already learned and how that's going to extend to what we're covering today. All right, so first off, what we did last time is we first wrote down what are P and Q, so we could come up with our possible rational roots. So again, P over Q is 2 over 1. And we want to write down all of the factors for P, so that would be 1 and 2. And all the factors of Q would just be 1. And then we could write down all of our possible rational roots. So we could have 1 and 2. Those are your only choices, okay? So from there, we would go and try and find one of our roots. So we don't have a whole lot of choices here. Let's start with 1. And we're going to synthetically divide, write down our coefficients, 1, -2, -1, and 2, and then we'll bring down the 1, and then we're going to multiply, and then we would add, and then we would multiply, and then we would add, and then we would multiply. It would end up getting a 0, which means that x equals 1 is one of our solutions, and then we'll end up having a quadratic left behind, so we'll have x squared minus 1x minus 2 is equal to 0, and now we just need to solve this quadratic. So we need to figure out what multiplies to -2x squared and could add to -1x. Okay, and again, we only have the only choice that could multiply to 2 would be 1 and 2. So we'll write 1 and 2, and we just need to choose the sign that would make it work. Okay, so since a is 1, we could write down our factors. We'll have x plus 1 and x minus 2. And then we just need to solve for each of those factors. So either x plus 1 has got to be equal to 0, or x minus 2 has got to be equal to 0, and we could solve those. So we'll end up getting x equals -1, or x equals +2. So our total roots would be x equals 1, -1, and 2. Okay, so that's what we did kind of last time. All right, so now we're going to go and look at this example. Okay, so again, we're going to start the same way where we will write down the possible rational roots. So again, this is our P. Q would be 1. So P over Q would give us 25 and 1. So again, if Q is 1, if the leading coefficient is 1, then you don't even really need to have the Q, because we're not going to have any fractions. So our possible rational roots would be plus or minus all the factors of 25. So 1, 5, and 25. Okay, so those are our only choices. And then we'll try some of these. We could do 1, and our coefficients would be 1, 5, -5, and -25. That's not a great 5. Let me try that again. Okay, bring down the 1. And again, while you do these, maybe it might take you a couple tries to get this to work. So you might want to use like draw it lightly with a pencil, or you could draw another every time, if another synthetic division, but that would take a little more time to write that all out. So anyways, so we'll multiply, we'll add, we'll multiply, we'll add, adding is hard. Okay, multiply, So that obviously isn't going to work. So again, you can just erase that part, and I'm going to try -1. So that would give us multiply to -1, and we'd get 4. It would multiply, would give us -4, would give us -9. Multiply would give us 9. So 1 or -1 isn't going to work for us, okay? So what we're going to try next is we're going to go to the next number. Whoop, that's not what I meant to do. We'll change that to maybe 5, okay? So 5 times 1 is 5, and we would end up getting 10. Multiply would get 50, and already I'm looking at this, I'm like, there's no way this is going to work out. I don't even know what this is, but it's definitely not 25. So let's go and try -5. Pretty sure this one's going to work, okay? So we'd get multiply gives us -5, gives us 0 when we add, and then we'd multiply, would add, would multiply, oh, and we got it. That's our 0, okay? So that's one of our solutions. And then we will write down our quadratic, so x squared minus 5 equals 0. Okay, so now you have to think, can you find something that would multiply to -5, sorry, and would add to 0? So the only things that can multiply to 5 are 1 and 5. Is there any way you could use 1 and 5 to give you 0? No. Okay, so this is not factorable. So we have two choices at this point. We could either use quadratic formula all the time. That works every time. Or if you have just one term with x, then we could do, we could solve for x. Okay, so that's what I'm going to attempt. So we're going to add 5 to both sides. So we'd end up getting x squared equals 5. And then to get rid of the square, we want to do its opposite, would be to square root. Okay, and we'd end up getting, x equals plus or minus the square root of 5. So those are two solutions, right? We have positive square root of 5, and we have negative square root of 5. So our total solutions we would have would be -5 from when we did synthetic division, and then we'd have square root of 5, and we would have the negative square root of 5. And that would be it, okay? So that's the way that we did it in like our problems in the past. We came up with those possible rational roots, and we kind of plugged that in. Maybe it took a second to find one that works, but it worked, okay? So I'm going to give you another example that kind of has the same sort of feel, but a different way to do it, okay? You need to make sure you look, because this doesn't work all the time. So if we multiply B and C, is it equal to when we multiply A and D? So if we did A times D, well, that's -12, right? It's 1 times -12. Is that the same as when we do B times C? So if we multiplied -3 and 4, that does give us -12. So if this happens, then there's kind of like a shorter way perhaps to do these types of problems. At least you don't have to like guess and check to find your first root, okay? So oftentimes for these problems, A is just going to be 1. So you could kind of think of it as, well, if we multiply these, is it equal to the constant? But again, that really only works if A is 1. So just keep that in mind. But anyways, so if that happens, okay, this is what's called a difference, or sorry, we can factor by grouping, okay? Factor by grouping is, you did this when you factor, like if A is not 1, you ended up using the box, right? So when you factor a quadratic, and you do like find the two things that multiply and add, we end up getting 4 terms, and we put those into the box. So here we already have 4 terms, and if this applies, then we can solve by grouping. So we would put x to the third, and then negative 3x squared, and then 4x, and negative 12. And then we'll just say GCF. What's the GCF for each row and column? So we'd get x squared, we'd get 4, we'd get x, and negative 3. And then we'll have these two factors. We'll have x minus 3 and x squared plus 4 is equal to 0. And then we could just solve, just like we did if we were solving a quadratic. We set each of the factors equal to 0. So either x minus 3 has got to be 0, or x squared plus 4 has got to be equal to 0. Okay, so let's solve those. We would add 3, and we'd get x equals 3, would be one of our solutions. And then here we'd have to subtract 4. And here we're not done, because we still have something squared. So that's where we would square root. Don't forget, when you square root, we have a plus and minus. So we'd end up getting x equals plus or minus. And we need to go back and talk about what is the square root of a negative, right? Like if you were to put that into your calculator, again, that would give you an error. But again, the definition is this, like I is equal to the square root of a negative 1, okay? So if we have a square root of a negative, that will give us an I, and the square root of 4 is 2, so we'd get 2I. So those are our 3 solutions. We'd have 3. That's a really bad 3. Let's try that one more time. 3, 2I, and negative 2I. Okay, so again, you'll probably see a few of these on the homework where you could like factor by grouping, but again, it doesn't always work. So if you're not going to remember like checking to see if these multiply to give us the constant, again, if you're just going to use the box, make sure you check and make sure it actually multiplies correctly. So we could multiply those, and that does give us x to the third. We could do x times 4, and that gives us 4x. We could multiply x squared times negative 3, and that works out. And then we could multiply these two, and that gives us the right thing. So if you check that too, that's helpful to see if it works. But okay, so if we looked at these other examples that we already skipped, again, if we were to, since a is 1, we could just say, oh, those multiplied is equal to negative 25, so that would have worked. We could multiply these two, that gives us a positive 2, yeah, so that would have worked, okay. But again, not all of them will work. So if you just want to stay with what we've been doing in the past, and then you don't have to worry about it. But if you want to have another option, another thing in your tool belt, that's good too. Okay, so let's look at this one. We kind of talked about this in our last lesson. What should we do first before we try and do anything else? We should always check for GCF. So here the GCF is, looks like 2x. So we're going to pull out a 2x, and we would get 6x squared minus 1x minus 1. Okay, so this is another like great idea. Plus, like if you're trying to come up with your p, like what is your constant? We don't have a constant. It would be 0. So then your only choice, the only factor for 0 would just be 0, right? I guess that doesn't really make sense. So just make sure if there's no constant, take out an x, and then you're good. Okay, so then we'll just want to find what multiplies to negative 6x squared and adds to negative 1x. So we could do something like negative 3 and 2. I think that would work. So we'd have, oh, but watch out here, we can't use the shortcut. So it's not x minus 3 and x plus 2, right? It's not that. A isn't 1. So we would need to use factor by grouping, or the box, okay? So we would put the first in your first, last in the last, and then negative 3x and 2x would be our puzzle, and we'll just say greatest common factor. So we'll have 3x, 1, 2x, and negative 1. Again, we can multiply and make sure that works out. Looks like it's good. So we'll have 2x, and then 2x minus 1, 3x plus 1 equals 0. So again, we're going to set each of those factors to 0. So we have 3 x's, we should have 3 factors. So we'd have x equals 0. So that's one of our factors. This is also a factor, so 2x minus 1 is equal to 0. And our last would be 3x plus 1 has got to be equal to 0. Okay? So we already have one of our solutions would be 0. And then we'd have to add 1. And then divide by 2. And that would be our second solution. And then for the last, we would subtract 1. Oh, that was not great. 3x equals negative 1. And then we'd divide both sides by 3. And that would give us our last solution. So we'll end up getting our roots would be 0, 1/2, negative 1/3. Okay? All right. So there is also another type of problem that if you can see it, careful, like notice the difference, the special type of equation, then we're going to find an easier way to do these types of problems too. Okay? So if you look at this one, it goes 4, and then 2, and then a constant. Okay? So if you see something like that, then we could do something called solving by U substitution. Basically, we're going to take something that looks a little hairy, like a 4th degree polynomial, and make it look like a quadratic. So if you ever have something that looks like this, basically it's like this would be like x to the 0. So basically we're like counting by 2's, like 0, 2, 4. You could also, it also works if you have like, if it counts by 3's, like 0, 3, 6, and so forth, but you're only going to run into ones that have 0, 2, 4. Okay, so anyways, if you see something like this, then we can simplify it by saying, oh, let's say if we have an x squared, let's gonna replace it with a different variable. We'll just call it u. Okay, so here this would be x squared squared. So when we substitute, we're going to end up getting u squared minus 5 times u minus 36. So it ends up turning this 4th degree polynomial into a quadratic. It's not really a quadratic because we're going to have to substitute it back eventually, but at least we can solve this part by factoring. Okay, so what could multiply to negative 36 and could add to negative 5? Okay, so again, I always get stuck if we have bigger numbers, so I'm going to start writing down things that can multiply. And then let's see if you can figure it out before I finish. So 3 and I think 12, 4 and 9, and 6 and 6. Okay, so those are our factor pairs. Which of those could give us a negative 5? Right, I think so. It's this one, right? So we'd have like 4 and negative 9. So 4 minus 9 would give us negative 5. So we'll have u plus 4 and u minus 9. Okay, so now that we have it factored, we can plug our u back in. I put our x squared back in for the u. So we're going to undo what we did at the beginning. So we're going to get y equals x squared plus 4 and x squared minus 9. So these are great because we can actually solve these factors. So either we would say that x squared plus 4 is going to be equal to 0, or x squared minus 9 is going to be equal to 0. So we would add 4, x squared equals 4, and then we'd have the square root, and we'd get x equals plus or minus 2. So that's 2 of our solutions, and then we'll do the same. Here we would, oh, sorry, I messed that up, didn't I? Oh boy, pause, sorry. This should have been subtracting. Let's try this one more time. My bad. So we'd subtract 4, so we get x squared equals negative 4. Then we would square root, and we'd get x equals plus or minus 2i. Okay? And then on the other, we would add 9. We'd square root both sides, and we'd get x equals plus or minus 3. So those would be our 4 solutions. We'd have 2i, negative 2i, 3, and negative 3. All right, okay. If you'd like to give B a try, I think I'm going to skip that just for the sake of the video. But yeah, so if you see something that is a degree of 4, check and see if it counts down to 2. So 4, 2, constant, okay? Again, you could write down the possible rational roots. You could do synthetic division, but if you do that, you would need to do it twice to get to a quadratic. So you can't just do it one time. You have to divide out or find 2 roots before you could solve by the quadratic. Yeah, okay? All right, I think I ended up after that. There's like 4 more problems. I'm only going to go over this one. I didn't mean to leave that up, so there's a little hint. Okay, so here is a 4th degree polynomial that doesn't match that pattern. So I'm showing you an example. Also, this is, I think, our example where we're going to have the quadratic formula. So this one has an x in every term, so that means we can factor out an x, and we'd end up getting x cubed minus 5x squared minus 7x plus 51 is equal to 0. Okay, and then there's no tricks here. We can't find anything that would kind of make this work, and so we would just need to do synthetic division. We need to find those rational roots. So P over Q, that's 51 over 1. And the factors of 51, this one's a little trickier. It's going to be 1, I think 3, if I can remember, 3 times what? I can't remember what that is. 51 divided 3, 17. Yeah, that's a tricky one. And then 51. Okay, so those are our possible rational roots. Again, I promise I may try to make the homework and the test so that you wouldn't have to get too far. Usually it's one of your first 2, okay, maybe 3. So let's give this a go. Again, write lightly in case you need to erase. Okay, we're ready to go. So we're going to multiply add, multiply, add, multiply, and that's not 0. Okay, so 1's out. Can't do that. Again, you can also do this using your calculator if you ever want to just like multiply and then add and multiply, add. Okay, this would give us what? -1, add, multiply, add, multiply, add. No, that doesn't work either. So my guess is it's probably one of the 3's. So let's cross that off and try 3. And if it's not 3, let's do -3. So multiply, add, multiply, add, multiply. I know that's not 51, right? Because it would have to be 17 to give us 51. So that doesn't work. So then let's try -3. So multiply, add, multiply, what's that, 24, and then we'd get 17. Ooh, this is good. And we'd multiply would give us -51. So we end up getting 0. Okay, so now we have a quadratic. We've got x squared minus 8x plus 17 is equal to 0. So I'm going to write this here so I don't forget. So one of our solutions is x equals -3. Okay, so now let's try factoring. Can we factor this? Is there something that can multiply to 17 and add to -8? Again, the only things that can go into 17, only factors of 17 are 1 and 17. There's no way you can use 1 and 17 to get you a -8. So here is an example where we would have to use the quadratic formula. Okay, we don't have an x by itself, so we can't use square roots to solve. So we'll need to do the quadratic formula. You can also do complete the square, but I figure we might as well stick with the quadratic formula because that always works, okay? So I'm going to write this out again. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to substitute. This is our a is 1, b is 8, and c is 17. So we'll get -8 plus or minus the square root. So watch out, when b is negative, it's not going to stay. It's going to become positive, right? Because it's a negative, okay? So then we'll have -8 squared minus 4 times a times c, and then all over 2 times a. So then we just need to figure out, we just need to simplify, okay? So we're going to simplify what's inside of the square root. So if you have a calculator, type in -8 squared. You do that too at the same time. So, and then type subtract 4 times 1 times 17. Gosh, sorry, one sec. I thought I was going to do this in my head, and I decided I probably shouldn't do that. So, there we go. So I end up getting okay, there we go. So I ended up getting -4. So we've got x equals 8 plus or minus the square root of -4 all over 2. Okay, so the next thing that we want to do is simplify the root. So we actually can do the square root of 4. That's just 2. And the square root of a negative is imaginary. So we'll end up getting 8 plus or minus 2i over 2. And then after that, we can try and simplify the fraction. So we'd end up getting 4 plus or minus 1i. And that's your answer. Okay, so we have x equals -3, comma, 4 plus 1i, and 4 minus 1i. Okay, so just one little thing I've had people do is just remember when you simplify the fraction, you can't divide something that's in a root, like you can't go like this. Like if you had something like that, that is not this, right? So you cannot divide something that's in a root by something that's out of a root, or vice versa, okay? So you would need to simplify it, so you'd instead getting 2 square roots of 2 over 2, and then we can simplify, okay? Just a reminder, since we didn't have to do that here, let's do an example. So the square root of 8, if you want to simplify a root, that's where we do like the factor trees, and we take a group. So every group will come out in the front, because what we're doing really is the square root of, this is just 4. So the square root of 4 is 2, and then we have a 2 that's not in a group, and you can't simplify the square root of 2. Okay, and again, like I said, if you had 2 on the bottom, then we could simplify. Okay, I guess it would probably be more like, I don't know, something like this instead. And then you could simplify the 3 numbers. So we get 2 plus or minus the square root of 2. Okay, anyways, so that's just kind of a side note. Let me know if you have any questions. That's pretty much it. I don't think there's going to be a lot where you have to do the quadratic formula. Most of the ones will be more like these, where you end up getting like the difference of squares or the sum of squares, or some of these that we did above, where you have like the square root of plus or minus the square root of 5. Stuff like that is the majority of what you'll see. Okay? Let me know if you have any questions. Hopefully that wasn't too bad, and we'll see you later.